So to add these two polynomials, what we're going to do is, since it's a plus, we simply just drop all the parentheses. If that was a minus, you'd have to change the sign of each of these, but it's not, it's a plus. But sometimes you can get a minus. So again, if it's a minus here, you'd have to change that to a positive and that to a negative, but it's not. So we have this right here. So we'd take the highest term first, which is that, nothing to combine with. Then we take the next terms, which are the x's, and there's them. I put 2 lines underneath, which is -5. And then lastly, you take the units that are left, and you combine those, which you get 5. And that's in standard form, and that's how you add two polynomials. Now, to multiply two polynomials, a little bit more work. I like to use this box. And since you see a trinomial times a trinomial, I have to make a box that has a 3 by 3 box. I put this on one side, and I put this on the other side. And then I do a little multiplication table. So I multiply these two, get this. Multiply these two, get that. Multiply those two, get that. Multiply those two, multiply those two, multiply these two, and multiply these two, and so forth. Once I multiply all those, then, as you can see with the yellow, you combine like terms, usually on diagonals. The like terms are usually on the diagonals, not always. And then you write it from the highest term down. So this is the highest term, so that's it. When you combine these two, you get 36 v cubes. When you combine all that, you get 14v squared. Combine that, you get -39v, and that 5's left over and nothing to combine with. And that's how you multiply. You can use a FOIL method where you do a whole bunch of multiplication. It totally works. I just like this because it's nice and organized. All right, and just also watch out. When you multiply like this, the powers are added, so be careful with that. Some people mess up with powers when they're multiplying, so be careful. And just be careful with your negatives and stuff, that you can get messed up by that as well. Next, we're going to do some division of polynomials. So, to do division, we do long division. It's going to be this divided by this, so we put this inside and this on the outside. And then what we do is you go, okay, what times 2x gives us 6x squared? And hopefully you can see that would be 3x. So 3x times 2x is 6x squared, and 3x times 2 is 6x. And then what we're doing here is we're subtracting down, those cancel, that'd be 14x. And then you bring down this little guy. Then you got to think, okay, what times 2x gives you 14x? And that would be 7. 7 times 2x is 14x. 7 times 2 is 14. And then we're going to subtract down again, and if you notice, they all cancel out. So we have a remainder of 0. Remainder of 0. Our quotient is right there, which is 3x plus 7. We just divided. And what's interesting is that right there is a factor of that polynomial, because you have a remainder of 0. So use the remainder theorem to find p of -2 for this function p. Specify the quotient, the remainder, associated division, and the value of p of -2. Okay, so to find p of -2, you could simply plug in -2 in for x, but it's a lot easier to use synthetic division using the -2. So I'm using synthetic division, the -2 goes there, and these numbers are the coefficients of this polynomial. Now you might wonder, where's that 0 come from? Because there's a 0x right here. Since there's no x's, there's a 0x. So again, I took the coefficients of this polynomial, and I took this number, and that's what I'm dividing by using synthetic division. Bring down the -2, multiply these two, put it there, add down. Multiply -2 and 2, get -4, add down. Multiply -2 and 1, get -2, add down. Multiply -2 and -2, get 4, add down. That right there is my remainder. See the remainder? This right here is your quotient, but you have to understand that's your unit, that's your x, that's your x squared, and that right there is your cubic. Some people mess up writing this. They don't understand that these are the coefficients of the polynomial quotient. And the remainder is your p of -2. So that remainder is also your p of -2. So we are going to use the factor theorem to determine whether this is a factor for this polynomial. And then specifically, we're going to evaluate p and determine whether x minus 3 is a factor. So first thing you have to do is you have to realize if x minus 3 was a factor, then 3 would be a 0. To find out if 3 is a 0, you can plug 3 into every x and find p of 3. Or you can use synthetic with the 3. And I like synthetic. I think it's easier. Less mistakes than plugging 3 into this. Now be careful when you use synthetic. The 3 goes here. The negative, because that, negative 1. You have to realize there's a 0x, so we put a 0. Anyways, so now we bring down the negative 1. 3 times negative 1 is negative 3. Add down. 3 times negative 1 is negative 3. Add down. 3 times negative 3 is negative 9. Add down. I get a remainder of 0. Which what that means is when you plug in 3, you get 0 out. So p of 3 is 0, which means there's no remainder, which means that x minus 3 is a factor. Now, if this right here was anything but 0, x minus 3 would not be a factor. But since it is 0, x minus 3 is a factor.